So here's another example where we want to solve for x. So we're going to do the same thing. We're going to list our reference angle, what we know, and figure out what trig ratio would help us solve for x. So we know that our reference angle is 20 degrees. We know that hypotenuse is 95 meters. We don't know anything about the opposite side, and the adjacent side is x. So using our trig ratios in the acronym SOHCAHTOA, we don't know anything about the opposite side, so we can't use sine or tangent, which leaves us with cosine. I will say that when I was learning trig ratios, that writing out SOHCAHTOA helped me, but eventually I found that I didn't need it. Like I internalized the trig ratios, and so I could just look at what I'm given, look at this picture, and know that I have the adjacent and the hypotenuse, and just know that that's cosine. So if you're already ready to do that, like go for it. But if you're not, just write it out. Like that's not a big deal. So we're gonna use cosine and put in the information that we know to solve for x. So we know that we have cosine of our reference angle, 20 degrees. That's going to be the same number as x divided by 95. So to isolate our variable, we're just going to multiply both sides by 95, which leaves us with 95 times cosine of 20 degrees equals x. And so we're going to type in 95 times cosine of 20 in our calculator. Again, we're not going to type in 20 degrees because your calculator should be in degree mode. So your calculator is going to know that 20 represents degrees. However, it's really, really important that in your work on paper, you put the degree symbol. That way you're being precise, and when you start dealing with degrees and radians, you have to just make sure you know the difference, and so making sure you're in that habit now is going to help you later on. When you type this into your calculator, you're going to find that x is approximately, hold on, 89.3 meters. Don't forget now to put your units in. The last example, I included the units in my math. And in this case, I just put 95 without the units. So that is one way to do less writing, but it also lends itself to accidentally forgetting units. So make sure that you do that. All right, so we have another problem. We're solving for x. We know our reference angle is going to be 89 degrees. We have our hypotenuse is x, so that's what we're solving for. The side opposite 89 degrees is 53, and we don't know anything about our adjacent side. So if we don't know anything about the adjacent side, we can't use cosine or tangent, so we're going to use sine to solve for x. So we have sine right here. Do not say sin. It looks like sin, but it's the abbreviation for sine. So this problem, it's slightly more challenging to solve because now what we're solving for is in the denominator, but you just have like an extra step to do. So we're going to multiply both sides by x to get our variable out of the denominator, which leaves us with x times sine of 89 degrees set equal to 53. And now we can isolate our variable by dividing both sides by sine of 89 degrees. When we do this, make sure you're getting in the habit of closing your parenthesis right here. It may not matter for some of these problems, but later on when things get a little more complicated, a little more interesting, it could put you in a situation where you make some careless mistakes. When you do this, you're going to find that x is approximately 53.0 units. I'm just rounding to the nearest tenth. I think that's reasonable. If you want to round to the nearest hundredth or thousandth, that's fine. I don't know that rounding to the nearest whole is the best choice in this case, just to get a little more precision there, but there's no hard and fast rule for that. So some of you might be wondering, okay, so x is 53 and my leg is 53 units. Like how can your leg and your hypotenuse have the same length? Don't forget that you're approximating that x is actually just a little bit over 53, right? It looks like it's 53.00807,339. So it is slightly bigger than the leg. And you may notice that it's really, really close because you're dealing with an 89 degree and a 1 degree over here. So those side lengths are going to be very close in size. So in this problem, it looks really similar to what we've done before, but in this case, we're given both angle measures. And yeah, like the other problems, we could have just found the missing angle measures because we could just figure out, like with triangle sum theorem, what's missing. But with this case, like it just seems more obvious that you could use multiple options. So we're gonna look at, let's say that 67 degrees was our reference angle. Okay, so this is our reference angle. We have the hypotenuse no matter what, and x would be the adjacent. So we could solve using cosine, right? So let's try that, and then we'll explore using sine, just to see that there are multiple ways to solve some problems. So we would get that cosine of 67 degrees is equal to x divided by 39. We're going to multiply both sides by 39 to solve for x. and that's going to help us find the value of x. So x is approximately 15.2 yards. Now we're just going to explore using sine to solve for x and see how that's different. So in this case, if we're dealing with sine, we want to deal with the side opposite. So if we use 67 degrees as our reference angle, we don't know anything about the side opposite. So we don't want to use 67 degrees as the reference angle if we're using sine to solve. We want to use sine of 23 degrees because the side opposite that is x, and the hypotenuse is still 39 yards. So we're going to multiply both sides by 39 and then solve for x. So after multiplying both sides by 39, we find that x is approximately 15.2 yards. So regardless of which way you solve, you're still going to find that x has the same exact value. So in a case like this, you just have to decide which way is easiest and maybe which way just comes more naturally to you. Now we're going to take a closer look at example 4 to make sure that we understand what trig ratios are doing. So the second time we solved this, we found that sine of 23 degrees was equal to x over 39, which gave us that x was exactly 15.23851401 yards. So what's the relationship between sine of 23 degrees and 15.23851401 divided by 39? So let's explore that. Let's type that in our calculator. After typing sine of 23 degrees in the calculator and also the 15.23851401 divided by 39, I find that they both simplify to the same number, 0.390731125. And so the question is, why does that matter? Why does it make sense? Well, we've been talking about how sine of an angle is equal to the opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse. Tangent of an angle is equal to opposite over adjacent. So when you're taking sine, cosine, or tangent of an angle, that gives you a number. And that number is equivalent to the ratio of those side lengths that we have, which is why we're calling these trigonometric ratios. So talk to your neighbors, replay this slide if you need to. Make sure you're understanding why the trig ratios make sense and what they're really doing. And I also have to give credits to the people who let me use their slides. And now you're ready to go back and work on some practice problems to see how well you understood this material. And don't forget, you have partners for a reason to get help with. You have Google. You can also talk to me. So just try it out, see what you can do.